Hi, if you're watching this video, I'm guessing you've made robots before or robot cars, so maybe you've seen motors like this before. They're pretty common, they're pretty cheap, and easy to use. But if you made a robot with this before, you probably realized that it doesn't go very fast and it doesn't really have a lot of torque. I think there's a few reasons for that. Number one is the, the gearbox. It will slow down the output shaft, so it's going a lot slower than the motor itself. Maybe it's more useful speed, not too fast. Also, the circuit that you power this with might not be very efficient. And then also, generally, these are run at 5 volts. So in this video, I'm going to start to test 12 volts. So this is a 12 volt lead acid battery. And I have, I'm very excited, new motors that I ordered online. So let's have a look, see what's inside here. Okay, hopefully they're the same. So let's start with one. Interesting. Oh, and this is a kit, so it came with its own wheel, very flashy blue. And looks like let's open it. So it's got a metal mount, so that's good. Because I plan to 3D print my car, I could probably print something, but it's good to have a metal mount. It came with it. Some jumper wires, there's like, what, 6 here? Some screws, and then like a hub adapter with some set screws and an Allen key for them. Very cool. Okay, good. So at least I know that I have compatible parts, so I can connect the motor and not just have it run freely in space, but connect it to something. And then I have a wheel that I know will fit. Okay, so let's actually have a look at the motor. All right, don't need that. Ta-da. Okay, so here we go. It's got like a D, so it's got a flat side here. It's quite hard to turn. I don't know if that's good or bad. Not sure if that's good or bad. And it's got this black part here. So this black part is an encoder. And so each time this motor turns, there should be a certain number of pulses that come out of this encoder. And I think there's like 2 sets of pulses. So you can see which direction it's going. Either one turns on, then the other, or vice versa. So that's something I need to test out too. But seems to be pretty solid. I am a little concerned I can't turn that at all. I wonder if that's normal. We'll have to test this out. So I do plan to, in this video, get it going with the 12 volts. Hopefully there's the fact that it doesn't turn is not a problem. I can use the previous motor driver circuit from the previous videos. And I think I'm going to try and see if I can get some signals from the motor encoder and double check how many signals for 1 revolution. So let's get into that. All right, so some time has passed and I quickly put some pieces of wood together. Initially, I was just gonna have 1 motor on there such that the wheel wouldn't touch, but then I realized, oh, actually I'm gonna want to test both motors. So I kind of set this up so that in the future video, I can have both motors mounted. So why don't I go ahead and attach the motor. So the mount has 6 holes here, and there's 6 holes in the front of the motor. I'm just gonna probably only need a couple screws. So it comes with screws. it's easier if I stick the screw out and find the hole. Yep. Okay, so that's pretty solid. I think that should be okay. I'm just testing the motor, so not a lot of force against it. So here's the hub adapter, I guess you would call it, and it has 2 holes for the set screws, but there's only one flat surface on here. So I'm just going to, there's one screw in there, like a set screw, so I'm going to set that on top as far as it can go and use the Allen key to press the set screw into that flat spot. Okay, and actually I did do this earlier. I was able to turn the motor, so it does turn, luckily. And then it looks like this is the screw for the motor itself. So it's got a hexagonal end here. It's got a hexagonal hole. So I just seat that in there, and then there's no washer, so I guess the screw just goes right in. I don't think I have to do it super tight because it's that hexagonal shape that will turn. That will have the shaft turn the motor. Okay. Okay, so now that my motor is mounted, I think I can go back to the circuit I had last day. So the Arduino, the ground is connected, the potentiometer is connected, the button, put our dial on there, turn it all the way down so that when this all starts up, the motor shouldn't start running. And how am I going to do this? Okay. So everything should be set up. I just need to connect things together. So these batteries, they have a flat connection. I guess that's called a spade connector. It's got a hole in it. So I could put a wire through there and fill that hole with solder, and that would be a stable joint. But for this, hold on, I need one more thing. Okay, so I'm going to connect. So since it has these flat connectors, I'm going to use alligator clips, and then I'm just going to use just pins to stick in the board so that the alligator clips can clip onto them. Now, I'm not sure if there should be a specific order, but let's get these set up. So the back of the motor has, looks like the 2 windings each have their own connector out here, separate from the JST connectors. So I'm going to use these little hooks, hook onto each one, so hopefully they don't run away. And I'll show a picture of that. And then these will go into our outputs of the motor driver. Okay. I am going to plug in the Arduino now. So it is now powered, and I can see the LED light is on. And so now let's connect the motor. Okay, so I'm going to start with the ground. So I have 2 pins connected into the ground here. So everything will share the same ground. Hope my wires are long enough here. Okay, so that's going to connect onto here. Okay, and then I have another 2 pins connected to the V-in pin of our motor driver. Oh, so hopefully no shocks here. The last thing I do is actually have to plug in my breadboard power supply. So let me do that. Okay, so it's 3.3 volts. And that light is on. So right now there's nothing connected to this power rail, but this one's 3.3 volts. The Arduino is running at 5 volts, And the 12-volt battery is connected to our motor driver. And everything should be running. So I guess the next thing to do is to turn up the speed. I hear something. It's making a noise. And it's not moving. And that's pretty disappointing. Okay, so I'm back. That took a little while. It took me a while to figure out that the 5-volt wire was not in the right row of the breadboard. So the potentiometer and the logic level converter weren't getting the right voltage. But everything's hooked up and it seems to be working. I'm having trouble with this potentiometer. I even switched out for a few different ones, but the connection in the breadboard is not great. Anyways, everything's connected now, 3.3 volts, 5 volts from the Arduino, the Uno, and 12 volts from the battery. So if I turn up the potentiometer, okay, and if I turn it up more, and if I turn it, there's about halfway. And if I press the button, it does have some trouble going in the other direction, but if I give it a little push, it does. It seems to be working. It's not as fast as I thought it would be, but it does have a lot more torque than the yellow motor does. So I think the next thing I'd like to do is play around with the encoder on the back and see if I can get a signal from that. So let's try that out. Okay, so just to kind of recap, so this rail through the breadboard power supply is set up for 3.3 volts. This side, although this is set up for 5 volts, nothing is plugged into this positive rail here. The Arduino itself runs on a battery, which runs at 5 volts, and that 5 volts is connected to the potentiometer and this logic level converter, the 5-volt side. Again, it's not used, and then the battery, my 12-volt battery, was connected to the VIN of the motor driver, and then this here, these 2 pins are what I connected for the ground, right? So those 2 pins for 12 volts, and these were the ground of our battery. Okay, so that was the previous setup. So now the last thing I want to show or look at is this encoder here. And it should be able to run on 3.3 volts. And it's kind of separate from the motor itself, but it does signal the rotation of the motor. It should anyways. So let me show a picture, a photograph I took earlier of the 6 lead connector on the back. So the top and the bottom are red and white. So those are for the motor windings, and those are what move the motor. Okay, those are connected to the output of our motor driver. Then the next 2 are black and blue. So here, so black and blue coming out of this white connection. So the black is the ground for this encoder. So that's connected to this black, which is connected to the ground here. So everything shares a common ground. And then the blue is connected to this blue, is connected to the 3.3 volts. So that's the VCC and the ground for this encoder. And then the last 2 wires are yellow and green. So here is the yellow connected to here, and here's the green connected to this green. And they are connected to this little breadboard, which has a green and a yellow LED. And those have each a 1000 ohm resistor in the same common connection, which is connected to ground here. And remember, all the grounds are connected, common. Okay, of the motor, of the encoder, this rail, the Arduino. Okay, so as you can see, the battery's not even plugged in. So I think that I should be able to get this encoder, these LEDs, to light up if I power this and turn the wheel. So I haven't actually done this. So here's my little, it's a piece of tape so I can keep track of the rotation. And it's at the very top from my point of view. And I think if I just plug in, so you see the motor is not plugged in, the Arduino is not plugged in. And now 3.3 volts is connected. So now this should be powered. And actually this LED is actually on right now. Let me see. Let me turn this light off. Interesting. So this LED is actually on, and it's only 1,000, or it is 1,000 ohm, which is kind of high for LEDs, but I don't know how much current this line is meant to source. So if I turn this wheel slowly, I was hoping to get a stronger signal. Like it is, I don't know if you can see it. It is flickering. The yellow is on. I do see the green flicker, but it's not on nearly as much as yellow. It is flickering though. I was hoping that it was more discrete, like changes, and so I could be able to count, but actually, so there the green is on. So I think actually what I need to do is, let me change use resistor because I can't see this green. I think that's what's happening. Okay, so I'm back. So I took out the green LED and put in red one because green just wasn't very bright. I tried a 220 ohm resistor, so there'd be 5 times the amount of current going through it, but it just wasn't bright enough. So I have a red LED on the green line with a 1,000 ohm resistor, and so you can see, so there the red is on, but it's very hard to turn it slow enough to, so there's yellow on, red is on, but it flickers. So it's very hard to see, to count discrete switches on and off. I mean, I can look at the data sheet and see how many pulses per revolution, but it's just too much. But at least I can see sometimes the red is on by itself. Sometimes the yellow is on by itself. Sometimes they're both on. So I guess the last thing so I was hoping I'd be able to count the number of revolutions, but I can't. So the last thing I'll do is I will just power up the Arduino and the 12 volts and just kind of see what it looks like when the motor's actually running. So if I turn this up, you can hear it buzzing, and that's going. So I was hoping to be able to see distinct flashes on the LEDs, but they both look like they're on. So I think it's just flashing faster than what I can perceive. But if I turn it off, so they're both on there. So there, just the red is on, the yellow is off. So I think it is working. It just doesn't happen slow enough for me to see, which I guess then would make sense if you want to really get more resolution and figuring out how fast this motor turns, then you do want these flashing a little bit faster. Okay, so I think that's it for this video. I was able to get the motor working with the 12 volt battery and the motor driver, so that was a good success. I can control speed and direction. I was able to get the encoder working, and I could see that it does look like there are pulses, but they're just too fast for me to see through an LED. So I was hoping that was something visual I can show, but it's just the frequency is just too fast. An interesting thing is that the motor seems to turn at a lower PWM signal in one direction, but not be able to turn the other direction at that slow speed. So something like having an encoder could let the microcontroller know how fast the wheel is turning at a given PWM signal and increase it to get it to go faster. And once it starts moving, probably reduce it to go at a slow speed. It just needs that first little bump to get it moving. So that is something that you could, I guess, do with this encoder signal. But that's something for another video. So I'm going to wrap this up here. Thanks for watching, and I will see you in the next video.